Okay, so here we're going to practice, writing each number as a rational number. Okay, writing each number as a rational number. So we already said that whenever we're writing these numbers, or whatever number they give us, whether it be a mixed number, a decimal, or an integer, a positive or negative whole number, that we have to turn them into fractions. So here we're going to practice that. So let's see, write each rational number as a over b. Well, whenever you see a over b, guys, it just means rational, and it means fraction, to write it in fraction form. So just make note of that. Anytime you see a over b, it just means make it into a fraction, a over b, a number over another number, numerator over denominator, So in number 3, we have negative 15. Now, negative 15 is an integer. Negative 15 is an integer. Our rules say that whenever we have an integer, all we have to do is put it over 1 to make it into a fraction. So if my number is negative 15, and all I have to do is put it over 1, to have a fraction, my fraction becomes negative 15 over 1. Negative 15 over 1. And I'm done. That's it. Very simple. And this is converting integers to a fraction. Integers to a fraction. For number 4, here we have a decimal. We have a decimal. So we're going to have to go from decimal to fraction. Well, for decimal to fraction, we said we have to make sure that we understand what number it is and go by its place value. In this case, the place value that I'm going to focus on is, listen to the number. We have 31 hundredths. 31 hundredths. So up to what place value does this number go to?
Hundredths.
Very good. The hundredths. This goes all the way to the hundredths. Hundredths. So now that we know the place value, that's going to be the number that we write as a denominator. So what number does hundredths sound like?
100.
Very good. 100. So I'm going to put that as my denominator. And all I have to do is write my remaining decimal, my remaining part over that one. So in this case, it's going to be 31. So my fraction becomes 31 over 100. 31 hundredths, is the same thing as 31 over 100. Very good. And that's decimal to a fraction. Very good. Number 5, we have a mixed number fraction, or a mixed fraction, and we have to go to improper fraction. And the way we do that, is by multiplying, then adding. Multiply, then adding. Well, the first thing I need to multiply is my whole number times my denominator. So in this case, I'm going to multiply 4 times 9. What's 4 times 9?
36.
36. 4 times 9 is 36. But I'm not done. My second step says to go ahead and add the numerator. In this case, my numerator is 5. So I have 36 plus 5. So what is the sum of 36 plus 5?
41.
41. 41 becomes my new numerator. So I'm going to write 41 as my numerator. And because we have to have a fraction, what do I have to keep?
The denominator.
The denominator. What's my denominator in this case?
9.
Very good. We keep the same denominator. In this case, it's going to be 9. So we have 41 over 9. Very good. Very good. For number 6, we have a whole number, or we have another integer. We have an integer here. So we have an integer. What is the rule for integer? What did we say it was?
Put it over 1.
Very good. In order for us to make a whole number into a fraction, we had just put it over 1. So I'm going to put 62 over 1. And now I have a fraction there. These are the 4 types, or the 4 common problems that we're going to be working on. And we have to know how to convert each one into a fraction. Each one has its own rule. For integers, all we have to do is put a 1 underneath it. Okay, if it's a negative number, a negative whole number, we put a 1 underneath it. If it's a whole number, we put a 1 underneath it. It's going to make it into a fraction. If it's a decimal, we have to listen to the place value. Okay, read it out loud, and whatever place value it is, if it's a tenth, we'll put it over a 10. If it's 100, we'll put it over 100. If it's thousands, we'll put it over 1,000. Okay, depending on the place value, that's how you're going to make your fraction. And for a mixed fraction, okay, you're going to have to multiply the whole number times the denominator and then add the numerator. Okay, very good. Okay, so here in this example, okay, we're trying to classify the three types of numbers, okay, in a Venn diagram. Okay, we already said that whole numbers are from 0 to infinity, okay. Integers were positive and negative whole numbers, okay, positive and negative whole numbers. So I'm going to write that down there inside that one. Positive and negative whole numbers. Positive, negative whole numbers. Okay. Positive, negative whole numbers. Okay. And rational numbers, okay, were numbers with parts. Okay. And what kind of numbers have parts?
Fractions.
Very good. Fractions is one thing. Fractions. What else? Fractions. What else? There's one more thing.
Decimals.
Very good. Decimals. Okay. Fractions and decimals are both numbers with parts. Okay, they're not whole. Okay, they're incomplete. Okay, they have parts something. So now that we know what each one means, okay, let's take a look at the numbers that we have. Okay, we have 14.1, 7 1/5, -8, and 101. So the first thing we want to do is put them where they belong. Let's put them in the right circle that they belong. I know I changed up the colors a little bit from the last example I gave you, okay, but the same idea still follows. Okay, so number 9 says 14.1. Okay, where does 14.1 fit in? What kind of...
Rational.
Very good. So I'm going to put it here. 14.1. Okay, how do we know it belongs there?
It has a decimal.
Very good. It has a decimal. Okay, it has a decimal. Okay, look at 7 1/5. Okay, where would 7 1/5 belong to?
Rational again.
Rational again. How do we know it belongs in rational again?
Because it's a fraction.
Because it has a fraction. Very good. Because it has a fraction attached to it. It has a number with a part to it. The 1/5 is the part. Very good. What about -8?
Integers.
Integers. Okay. Why? Why is -8 an integer?
Because it's a negative.
Very good. It's a negative whole number. Very good. It's a negative whole number. Okay. And the last number we have is 101. Okay, 101. Okay. Where would that one go?
Whole numbers.
Whole numbers, because it's a number between 0 and infinity. Okay, very good. Okay, so now that we classified each of those numbers, okay, now let's go back and put the label on each number. Okay, so what did we say 14.1 was?
Rational.
Rational. So I'm going to write rational there. Okay, rational. Okay, and can we put that rational bowl into anything else?
No.
No, because it doesn't fit anywhere. Okay, so that's just going to stay as rational. Very good. Okay, what about number 10? 7 1/5. What kind of number do we have there?
Rational again.
Rational again. Okay, and we already said that if it's rational, it's only by itself because it's too big. Okay, we cannot combine those sets of numbers into anything else. Okay. Number 11, we have -8. Okay, -8. What kind of number do we have in -8?
Integers.
Integers. Very good. Okay, this is considered an integer. Okay, now, can my integer bowl fit inside anything else?
A rational.
Very good. Okay. My integers numbers can also be called rational numbers, even though they don't have parts. Okay. They can still be called rationals because if we convert this -8, okay, if I convert it into a fraction, what can I put it over?
1.
Very good. Is this a fraction now?
Yes.
Yes, but it's also a whole number because -8 divided by 1 still gives me -8. So it fits in both of them. Very good. Okay, very good. Okay, so integer numbers are also rational numbers. Integer numbers are also rational numbers. Rational numbers are not integers. Okay, integers are rational, but rational are not integers. Okay, we have to know it. The way we say it, okay, is going to make a big difference. Okay, number 12, we have what kind of number there?
Whole number.
A whole number. Okay, and if it's a whole number, where else does it fit?
Integers and rationals.
Very good. Okay, very good. Okay, if it's a whole number, it fits in integers as well. Okay, and rational as well. Okay, very good. Okay, very good. Okay, we have to make sure that we understand that. Okay, those are going to be very common questions that we find. Okay, making sure that we can put the right label on these numbers. Okay, making sure we can put the right label to these numbers. Okay, very good.